Welcome to the Deep Dive, the advanced web development podcast brought to you by indev.dev. Hi people, today we have two guests with us here on the Deep Dive podcast show. And the first guest is a lead instructor at Trilon. He's the creator of the upcoming NgRx Component package. He's the creator of the RxAngular and RxJS state libraries. And he's one of only two people in the world to have worn the Rx wizard hat. He's also the discoverer of quantum rubber duck debugging. And his tagline is, "The AsyncPipe is boring." A little fun fact about this guest of honor today is that every year at the NG Poland conference, before the doors are opened, he gets on stage and then he sings a cappella for the crew while they set up all the audio equipment. Please welcome Michael Hladky.
Thanks, Lars. Wonderful introduction.
Anything to add?
No, I mean you got pretty much everything and added a lot of more fun stuff on top. I guess this was one of the coolest introductions I've ever got. Thanks for it.
Nice.
I should write it down somewhere.
So we have a second guest today, and this guest is the author of 3 books about Angular. The most comprehensive one is called Angular Architecture Patterns. He's the host of the Angular Architecture podcast. He's the creator of the Angular Rules Engine library for input validation and business validation. He also plays tenor, alto, and soprano saxophones, and more or less has a recording studio at home. He was supposed to be a smooth jazz sax artist, but somewhere in life he took a wrong turn, and now he codes for a living. Please welcome Matt Vaughn.
Thank you, Lars. Great introduction there. Yep, that's it. I should have never been a coder, but here I am.
What were you supposed to be, Michael?
Well, I had a couple of different funny jobs. The first thing was I was selling ice cream when I was very young, and then I studied electrotechnical stuff, and then I switched to economical whatever studies, and finally I ended up in IT. And to get, I guess, the most important funny fact about me, I was at the opera for 8 years, working every summer and longer to help them. First I was on stage, not acting, but like playing the people in the background. Then I was setting up the stage building, and now I come to the interesting part. Aida is one opera, and there were elephants, and my role was to walk behind the elephants with a big wagon where you can carry heavy stuff. And when the elephant were in the middle of the stage, there was like planned a stop. And every time when the elephant stopped in the middle of the stage, and you have to know there are 4,700 people watching the elephant stopping in the middle of this gigantic stage, he took a dump. And I was there for his poo. And then I dig this huge ball of shit into this wagon, and I got applauded from 4,700 people. It was incredibly cool.
Best job ever.
Yeah.
You learn how to take care of legacy. Okay.
So what are we going to talk today?
Let's move on to the topic of the day. Today's topic is Mythbusting the AsyncPipe. The AsyncPipe is a really common and central piece of the Angular framework. It does a lot of nice things, but you need to dig a little deeper if you want to focus on performance, because it has some limitations and it has to do with some other stuff in the Angular framework as well. So it's not you can only look at this single piece and evaluate, well, this will give you good performance in your complex application. So I'm kind of curious to hear your thoughts on this, Michael. What do we need to learn to understand the AsyncPipe and its limitations?
Well, to use the AsyncPipe, you have to have a little bit of a clue about RxJS. But for me, the most important part to get the bigger picture is to understand what Zone does to Angular and how change detection is working in Angular. Because Angular is one of a very, very few front-end frameworks out there that is not like manually triggering the rendering of the view somehow. And in fact, we don't really do it in Angular. We just guess that we should do it because of zone. And I guess this is a very, very hard to grasp topic. At least for me, it took me like a long time to really understand the full impact of what zone is doing to our developer culture, but also to the performance of our application. Maybe we should clarify how changes are propagated within Angular in a very, very simple example.
Yes, let's do
I think that would be great. Yeah. So I have a question, I guess. So before async observables, what were Angular developers doing before that? And how did we get to the need for async observables? Because I don't think they didn't exist early on, right?
Well, RxJS was here before Angular. And we used promises back then a lot, which is a one-shot observable that is not cancelable, I would say, is a good rough explanation for it. And why do we need it? Well, we have a lot of things that change often. For example, the URL, right? If you change a parameter in the URL, it changes, and you cannot always say, give me a new promise, and when this resolves, give me a new promise. So having something that is like a promise but with multiple values is a big thing, I guess, for everything that is interactive, and the web is interactive, the browser.
So you mentioned propagation of changes. Michael, how would you explain that?
Well, I would start to ask the question, how is the first render done in Angular? What happens to that we see some DOM? And we maybe know that in the root module, there is a component that we bootstrap. Normally it's the app component. You have it under this bootstrap slot in the module decorator. And then when you start Angular, at some point, there is something that is called the application reference. And the application reference holds a reference to your root component and some logic inside, and I believe, Lars, you can correct me very well here because I'm not that deep into this part. Somewhere in there, there is a method that is called ApplicationRef.tick. And this tick, and now I have to ask, after this sentence, I have to ask Lars what the tick is really doing, but something in the tick starts the rendering of the first component, and the evaluation, the detection of changes for their child component, or let's say the re-rendering of their child component, and then the re-rendering of their child component. And in the end, all components are rendered and the app is idle again.
Yeah.
So what happens in this tick?
the ApplicationRef.tick, that's kind of where the synchronous change detection cycle is kicked off, where it goes through the whole component tree, or probably to be more precise, the tree of change detectors, where they all hold these values. I guess we'll talk some more about that. But anyways, the ApplicationRef.tick is kind of, you can even call it yourself, and it'll schedule or trigger immediately a synchronous change detection cycle, going through all the components and kind of evaluating whether they need dirty checking, which is a different thing than just the change detection cycle. So the change detection cycle is to figure out which component do we need to do dirty checking on, and if they are indeed dirty, they need to call the component views, which are bound to the DOM. That's at least how I understand it in my head at this point.
So maybe some interesting discovery that I did, because I guess all my knowledge about this rendering stuff I developed in the last year or so. And for me, very, very interesting is if I have the change detection strategy to default, and I, let's say, set a value, and this value is connected over input bindings to other components, the assignment of the value will happen synchronously immediately, and then the view will get re-rendered. So when you have the default strategy, you can like hand over directly stuff, and then you have to wait until it is rendered. The second thing, when you switch from the default change detection to OnPush, this is not possible. And I was like very impressed about what should I do with this information now? I can hand over information directly over multiple components, but the rendering still will render anything. Maybe we can get back to this part here when we are at the point where we talk about scheduling or something like that.
And change detection strategies.
Yes.
So I have a question, Lars. You mentioned that change detectors. So there's a collection of those, or is it one change detector per component, or does a component have more than one?
Yeah, we kind of were experimenting with this, Michael, right? And we found out that there are actually quite a few change detectors. So the change detector ref is kind of a representation of this. It's the API you have to kind of interact with or manually trigger change detection on your component level. You can inject the change detector ref, and you can call detect changes or markForCheck. And this has been possible since the first version of Angular. But there's not even only one per component, because as soon as you have, let's say, a structural directive like ngIf, that embedded view, I believe it's called. Is that correct, Michael?
Yeah, embedded view.
Yeah, that has its own change detector, which is kind of tied to the view that holds it. So the view it's embedded in, so the components view data structure. And when we say view here, it's a data structure used by Angular to kind of do the dance of change detection and synchronizing to the DOM.
Okay. And for individuals who maybe are from like Angular JS world, is that similar or equivalent to like watchers? I've heard people talk about watchers in Angular JS, but maybe that's a little off topic, but I was just wondering if there was any correlation there.
So the process of watching is, watching changes of something is not present in Angular in that manner. It is only top-down propagation of state. And you can, of course, break this one-way data flow and use references to other components, but in general, it happens only top-down. And as far as I know, there is not a lot of pull-based logic that is watching something. I guess not a single pull-based code snippet.
And that's why in Angular JS times, kind of this whole digest cycle had to do several runs, because one run might trigger another change, so you had to do another run to make sure there was not additional changes, and you ended up at some point it was too many runs, so many that it kind of broke the whole thing.
So, because it was not one way, the data flow.
Yes. And now, so when we get this, what's it called, like expression changed after expression has been checked error or something like that, that's because in development mode, so not in production mode, but in development mode, it'll do an additional change detection cycle per cycle, just to make sure that stuff didn't change after the view has been synchronized with the DOM. Because if you change stuff after that point, it won't be synchronized to the DOM before the next change detection cycle. So Angular will do an additional change detection cycle to see if you have done something wrong in your code. So be very careful with that error. It's trying to tell you something. And at production mode, you won't even get the error. You will have updated something that will not be rendered to the DOM before the next change detection cycle happens at some point.
What happens if we switch the change detection strategy to OnPush for one or many components? Maybe we should talk about this.
Well, first, I think first let's talk about what is dirty checking at a component.
Yeah.
Can you explain that, Michael? Because I say change detection, dirty checking is one part of the change detection in Angular. This whole change detection cycle, like traversing the tree and figuring out which ones needs to be dirty checked. But then comes dirty checking. What happens at that part of change detection?
Well, I believe dirty checking happens only if we have the change detection strategy on push. Is this true?
Okay, so the way I have it figured out is that dirty checking is where it goes and evaluates the expression bindings and the property bindings and figures out whether, and it actually compares it to the previous value that it was evaluated to. And that tells Angular that so something has changed, so naturally you need to synchronize this to the DOM, view the view data structure. So dirty checking will happen in both change detection strategies, the default one and the OnPush one. But in the OnPush one, dirty checking will only happen if the input property values have changed. So there's kind of a gate there to say we won't run dirty checking unless your input property values have changed. Or you use AsyncPipe, but we'll I'll get back to that. So that's dirty checking, at least in my understanding, where it actually evaluates every binding and expression binding in the template.
So it's already in the template.
And that's why change detection strategy default can make too many evaluation, because every single async thing that happens, and then comes NgZone into the picture, and then comes ApplicationRef.tick into the picture, every single binding in your whole active component tree will be evaluated. And if you have some heavy computation, that can hurt your performance a lot.
That's true.
So that's dirty checking at the component level. But that's part of this whole change detection system. So then comes the change detection strategies. So who wants to try to explain that?
You said gate. Maybe let's talk a little bit about this gatekeeping stuff. So if you switch it, as you said, you can only pass values into this component when the expression or the comparison with the previous value with a triple equal sign is valid. So you have to work immutable. This is a side effect of this strategy, which pushes a little bit of cognitive load to the user, but I believe it's a nice practice. I mean, if you have non-immutable state changes, you're anyway on a bad path. So I guess this was a good decision to push the workload to the user. But the cool thing is how rendering then works, because if it goes only top down, you would not re-render not only this very component, but also all its children. So you could get rid of re-rendering of a whole component subtree.
Yes, that's right. So it's a gate to this component, but also its view children, and probably even its, well, that's where it gets hard. What about its content children? Because this thing is changing, right, even as we speak. How does this affect content children versus view children? Because at some point it was not even predictable. And now with Ivy, they have tried to fix it into a predictable way and the way they think is right. And we have even seen some differences between some of these views, like logical views and type views, as we have been testing this stuff between View Engine and Ivy for some of your crazy experiments, Michael. So I don't actually know how this affects content children, whether the gate is kept by its the component that projects this content or the component that declares this content.
I would have to look it up. I mean, I set it up over 25-ish different cases that you can run in with that you have to know what happens, and I could later on look it up. I'm pretty sure I have one of those examples running, but I don't know it in the top. Don't have it in the top of my head.
Okay.
I have a question for you guys. So I try to relate new information to things that I already know. So when we think about the change detection strategies, would you consider them similar to maybe a scope, like in a transactional scope for like database events or something? You can wrap that scope and limit or kind of encapsulate what gets modified in that within that scope. So is that what the change detection strategies do, is to provide kind of a scoping boundary for changes and handling those in the components?
I would say it's how the boundaries are evaluated. You have the boundaries already, and the strategy just tells you how you can pass something through this boundary.
Okay.
Right, but speaking of scopes, I mean, you have been experimenting a lot with this, Michael, and kind of optimize the rendering and the change detection by giving the user the option to define these scopes in a more granular way than what change detection strategy allows. Maybe you have a different word for it, but I would definitely consider it a scope for rendering or change detection.
Yeah, so I also use the word scoping, but so before we can talk about the scoping, we should clarify what coalescing means, and
let's save that for a bit later then.
Exactly. I would say we should see how we can go further with the rendering and finally come to Zone.js, the big evil in all our applications, and let's see what it does.
Okay.
So do you think we discussed change detection strategies enough, Matt?
I think so. Yeah. So how does I guess one of the questions is how does Angular know a component you talked about being marked as dirty? dirty checking. What causes that to happen from like a developer perspective? What do we need to know to work with change detection? But how do we know a component is dirty? When and where, or how does that take place?
Yeah, you can you can do it, and there's different ways. You can do it yourself through the change detector, and then the change detector ref has a method called markForCheck. It'll set a bit flag on the component view that says that it's dirty, meaning it needs dirty checking to evaluate whether it has to synchronize its view to the DOM. And what happens then is it's not enough to mark it as dirty, because now you're just waiting around for a change detection cycle to happen. But you know that it's dirty, so you want the change detection cycle as soon as possible. But like if every view or every component was requesting a change detection cycle every time a state change happened, we would see a lot of change detection cycle. And that's where coalescing comes into the picture, right, Michael?
Okay.
That's true.
And another example very relevant to this discussion is the AsyncPipe. Maybe you can try to explain that, Michael.
Let me add one thing to this one. You asked how is this dirty marking happening? And Lars explained how it is happening from within a component you call markForCheck, and then this component gets marked dirty, then its parent get marked dirty, and then its parent get marked dirty until you end up at the component root, the root component, and then the application ref calls ApplicationRef.tick, and then you walk down. Another way is if you are sitting in a component and you update a value, and then you call detect change. And what's then happening is that your template gets re-rendered, the input binding gets dirty checked, and if then the value is new or is like, let's say different to the previous one, then it will also get marked as dirty and directly re-rendered. So you can come from the top to bottom or bottom up.
You say the ApplicationRef.tick is called, but that's not called by calling markForCheck. So when does this happen?
So when you call markForCheck, you walk up the tree, and also you trigger an event in a zone. You trigger a small task in the zone, and then zone has a queue. Maybe we should first discuss what zone in general does before I explain the queue. But to finish it quickly, there is a queue where Zone collects a lot of asynchronous events, and when all of those are exhausted, when, for example, the specific thing here would be the microtask queue exhaust event, when this is happening, the ApplicationRef.tick gets called from Zone. So Zone is triggering the ApplicationRef.tick. So what is Zone doing? And I worked years with Angular until I realized what Zone really does. When I will say it now, it will get lost because so many people told me before and I was not realizing what an impact this means. Zone is patching the global API of all asynchronous things, of all asynchronous events that are out there. And whenever you call one of those APIs, and to give an example, the set timeout is such an API that is get patched. And when you use it, Zone will realize that you used it and then will re-render your application. And this means if you really try to save something, or let's say if you have just a background task that is ticking every 500 milliseconds, but not doing really anything special, Angular will re-render every 500 milliseconds because this API is patched. Same goes for a promise, same goes for everything else. And this is way more complicated than I thought, because those tools that I work on are here to get rid of Zone. And for example, if I want to collect a certain amount of emissions in a certain time frame with a promise or with a set timeout, and I want to save some change detection over Zone, I cannot use a promise or a timeout directly, because if I use it, Zone will again realize it. So what I ended up with is going to the window object, because on the window objects are symbols that maintain the original set timeout and the original promise. And whenever I want to use something asynchronous in the library internally, I just go to the window and take a look, is it patched by Zone? And if yes, I take the unpatched version. If no, I take the vanilla one. this is, I guess, critical for everybody that tries to work without Zone or zoneless. Don't use Zone in your applications if you try to work zoneless. In the end, you cannot migrate away from it if you rely on it all the time. This is, I guess, my biggest finding on working with zoneless applications in the last year. So Zone is interfering with everything, and when I call mark dirty, Zone will realize it, and then the ApplicationRef.tick is fired.
So is Zone a kind of an abstraction to the JavaScript event loop that's going on in the browser client?
No, Zone could also patch other functions, other browser APIs, synchronous browser APIs. You can basically patch an API with it and realize when somebody is using it.
Gotcha. Okay. And currently there is a way to disable Zone for certain operations and perhaps exchange that with maybe a worker service or some other mechanism.
So you have different ways to get rid of Zone. All of them are not here to migrate to a zoneless application. At least I could not really make a lot of use for it when migrating to zoneless. But what you can do is you can disable it completely in the main TS file and in the polyfills. What you also can do is you can disable the patching of certain browser APIs globally. You cannot really say, okay, I have this application and I want to migrate it to a zoneless application. So now let me only treat this single component as it would be zoneless, and then the next one, and then the next one, until I'm done with all the components and can really safely kick out Zone. Otherwise, it is really, really hard. So this mark dirty function, or this mark dirty call, this is also what happens in the AsyncPipe.
Well, isn't it markForCheck? Which is a different thing than mark dirty. There's one difference, right?
I always confuse. There is a big difference.
Yeah.
There is a huge difference. So markForCheck is the one that is called in the AsyncPipe, and mark dirty is another one that is already present as internal API, but will change a lot in the future.
Yeah, and that's kind of the reason why AsyncPipe can't work without NgZone, because AsyncPipe calls the change detector ref and the one relevant to the component or the embedded view, whatever, the change detector ref, and then markForCheck.
Exactly.
But then we need something to trigger that ApplicationRef.tick to kick off the change detection cycle, and that's NgZone.
Yes.
So does NgZone patch observables or what?
There are different problems with observables if you instantiate them in the same zone. It sounds crazy, but there are more zones that are connected to each other. If it happens, let's say in the same component, if you use a set interval or an interval observable in the component, it will render. If you hand it over from a service, it will not render. So there are different problems, and Jia Li, a brilliant programmer and maintainer of Zone.js, which I had a couple of discussions on this stuff, was providing a patch, and you can implement it as polyfill, and then it will work way better with observables than before. But then I guess you have a new problem that all your observables will trigger Zone.
Do you remember the AsyncPipe? I guess it also calls ApplicationRef.tick directly, or does it? No, it doesn't. No, it doesn't.
Only calls markForCheck.
Yes. So it relies on NgZone to call the ApplicationRef.tick because something async should have happened at the same time.
Exactly. So now as we understand the problem that the AsyncPipe will not work without Zone and also will over-render the stuff, we could think about solutions. And there is a pretty old solution out there. Rob Wormald talked about it, I guess, 2014 or 15, about the different ways how we could use observables. And there was also the idea of a push pipe and the let directive. These are pretty old ideas. And they had a big problem. And this is where we can start to talk about the local rendering and the problems that will occur there. So Rob said, or Rob realized that it will not work. And he was proposing and also demoing a way where you call change detector ref.detect changes. And this is a synchronous call that will not walk all your component ancestors up and mark them dirty and then wait for Zone to re-render the application. It will basically only re-render the very component where you are and all its children. Of course, in consideration of all the change detection strategies and dirty checking, but the process itself starts only from the very component downwards. And this is a huge difference, because you don't go up, mark everything as dirty, and when walking the tree up and marking those stuff as dirty, you potentially open up other component subtrees to get re-rendered without any change, because you marked this component as dirty and maybe they forgot to set the OnPush change detection strategy on the children. You don't always think about it, right? And then they will also get re-rendered. So whenever you go bottom up, everything on your path is in danger of a re-render. And the change detection strategy that uses detect changes is only from the very component downwards. But the big problem is that it is sync. So the call and the render call happens synchronously. And this is the reason why this didn't made it so far into the wild, because the over-rendering was pretty huge. Imagine you would use multiple push pipes and lex directives in your template. They would re-render and they receive the same value, for example, as a made-up example. Then every one of those would trigger a re-render. And if you have 5, you would have for one value change 5 re-renders, which is a lot, and which takes away all the benefits that you will get from this local rendering. And this is one of the main reasons why it didn't make it out there as a production-ready thing.
I actually went back and Git history on the Angular repositories, and in the beginning, you know, a long time ago, there was actually only one of these two. There was only, I believe it was detect changes. Mm-hmm. And what it did back then is kind of a mystery, but I could imagine that it was kind of like the, what was it called in AngularJS? Scope, what was it called? Scope apply or digest or something?
Yeah. Emitting of those values, root scope.
But that's kind of, that's like change detection for the whole component tree, the whole application. So that's more similar to ApplicationRef.tick. Mm-hmm. Right? So very early on, and I don't remember who did it, but I think it was either Victor Savkin who did this change or Mishko Hevery. But anyways, we ended up having these two to kind of be able to scope it more, either use detect changes or use the markForCheck. And then the AsyncPipe was changed to use the markForCheck. And that's where this whole thing started. There's a few more limitations of the AsyncPipe that I kind of want to discuss before we get into coalescing and scheduling of change detection.
So Michael, why is it boring? Why are async observables boring?
Well, because you could do way more with it. If you could first do the stuff that we discussed now. You can focus on only the very component and not the whole component path until to the top. And you can really control it with the AsyncPipe or control it with this let directive. And the other stuff is that you can use 2 techniques to really get the last bit of performance out of it. And this is, the one technique is called coalescing and the other one is scheduling. But I guess Lars wants to discuss some other stuff before we go to these 2 topics.
Yes. So the AsyncPipe, when a new value is emitted on an observable that you pipe through AsyncPipe, mm-hmm. What happens if it's the same value as the last emission?
So in the implementation in Angular, you receive an observable and then you subscribe to this observable. And let's stop here. Let's say somebody else calls another time render, and then you would evaluate the expression on the AsyncPipe and you would receive the same observable a second time. And this is the first check. So the AsyncPipe only subscribes to the past observable is if the instance of this observable is different than the previous one. This is the first check. And a lot of people that work with observables and getters, for example, if you have a getter that gives you an observable from a subject.asObservable, and this in a getter, you will receive, whenever you call the getter, a new instance of this observable. And this is how one of the bugs or the bug reports on the NgRx repository on the component package happened. And I took a look and I realized, okay, he is creating over and over new instances of the same observable, and this caused his end test loop. So this is the first check, the first layer. And the second layer is if we open up the observable and listen to its emitted values. And whenever a new value gets emitted, I store this value as last value emitted. And then I update the view and then I call markForCheck. And then the whole circle starts again. When the same value gets emitted, you will not re-render the you will not re-render the template only if distinct values are emitted. And this distinction is also done, implemented imperatively in the AsyncPipe.
Really? I was pretty sure that the same value emitted twice, like the same triple equals value, would trigger another markForCheck. It'll always trigger markForCheck regardless if it's the same value.
Interesting, because
I
only have my own implementation in the head, and there I for sure check everything that is double. But at least the first assignment is checked. I have it in my head that they check for the same instance of the observable. And maybe while our discussion, I can open up the source code and have a look about this check. But yeah, these checks are important if you ask me, because over-rendering is the most expensive thing you can do, right? You can have the most performant JavaScript part in your application that is possible. But if the rendering is not good, the rendering will draw all your performance away, because manipulating the DOM is super expensive. So much more expensive than updating some objects in your engine that there is no comparison.
So is dirty checking, by the way. I mean, if you have a lot of template expressions, they have to be evaluated and you're doing some heavy computation, then it can really hurt you if you're dirty checking all the time.
Yeah.
Hey, Michael, I have a question. You mentioned in the example, if you're using a getter to return an async observable for the view, in terms of performance, is that the correct thing to do? I wonder, because I once made the mistake of putting a logging statement in one of those getters. And it seemed like it just happened like thousands of times, like over and over again, so quickly. And I was wondering if the async observable was just not iterating, but making continuous calls to that to check. So I didn't know how that connected, but it seemed like a performance killer right there.
So getters in general work that way, that the view controls them. And when you bind a getter into the view and the view gets re-rendered, you call this getter. And if this getter internally has something that, for example, is patched by Zone, a log to a server or something, this will re-render, of course, again. And then you could end up in such unhappy situations.
Right.
We've spent a lot of time discussing this, so let's kind of move on to the last couple of topics we want to discuss.
Perfect.
Which one, coalescing or scheduling? Michael.
Let's focus on coalescing, because I guess this is where we can get the first big part of performance. And let me start with an example where you have, maybe let's start with an imperative example. Let's say we have a detect change method and we call it on multiple places in our component class. And if we do this in the class, let's say we do this in the setters of the input binding and we update those input bindings at the same time, we would have two render calls. So coalescing means, and is already also implemented in Angular, buffering a series of some events together for a certain time period and then using only the last, in my case, the last one of them. So what I do is, if you call change detector ref detect changes 100 of times, I will basically collect all those calls that are happening synchronously, and then I will schedule a promise. And a promise is a micro task. And the interesting part about a micro task is it is still synchronous code. So it will happen after the synchronous tasks are run, but still in the synchronous stack. So you lose no time, you don't schedule it at some point in the future. You just make sure that 100 emissions in the same browser event loop tick are digested only once. And this is where you can get rid of all those sync calls that happen parallel in the class. And then it gets very, very interesting. If you go to the components template and you work with some powerful stuff like directives or pipes, you trigger the change detection in those pipes, right? You hand over, for example, an observable or some other value, and those pipes and those directives call change detector.ref. And if you think about an observable, which would emit multiple synchronous values in the same browser tick, this is like what we did in the class. We coalesced all those multiple values together into one, and we only update a few ones for 5 synchronous emissions in this observable. But now let's think about a little bit more difficult problem. If we have not multiple values in the same directive, let's say we have multiple sync values in multiple directives. So an observable or a value is bound to 2 or 3 different directives or pipes in the template. And this happens a lot in practice out there. If you open up an Angular application, I'm pretty sure you will find it very, very soon. And in these situations, they are like independent universes. They don't know from each other. And even if they coalesced synchronous values for them, they would still, 3 push pipes would render 3 times the template. 3 let directives would render 3 times the template because they don't know from each other. How can they know that the first one and the second one still also called it synchronously? So you need a way to share a certain scope for this. And now we're getting back to this scoping topic that you started previously, Lars. I started to think, okay, what is a common thing that lives inside the component class, the component template, the component template's directives and pipes? And my first research was ending up with the L view in Ivy, which worked pretty good. But then I switched to the change detector ref.context, which is a reference to the instance of the component class. And this is also the same in all the different parts that I mentioned. And then I said, okay, now I have this reference. I could set a bit flag on this thing and tell all the others that have the same instance that they should not re-render because somebody else will do it in the future in the next micro task. For example, this was the first approach. And of course, it was very bad because I cannot take the component instance and set a property to it. maybe I call the property dirty flag and there is another property that is called dirty flag and I just overwrite it, right? So my second approach was using a symbol. And then I could put the symbol on this component class and it would not interfere with other properties. But still, not really good because I interfere with another part and maybe they will change the internal implementation of context from the component instance to something else. How would I know that I don't do something malicious to this foreign thing? So what I did then is I created a WeakMap, and the WeakMap was enabling me to store a certain set of properties, or in my case, the bit flag, for a certain instance without manipulating the instance itself. And when the directive or the push pipe gets destroyed, the WeakMap by nature will also do the garbage collecting and I can free the space. So this was a very, very nice way to set this bit flag on my context, on my scope. And with this trick, I was able to share the same constant scope, the same instance in my component class, and in everything that lives in my component template, speaking of directives, pipes, and other stuff. And this, in the end, brought this first huge chunk of performance improvement. I have a very, very simple demo that shows that Angular natively re-renders the component 12 times if you use it. And if you bring in Coalescing, it re-renders 4 times. And if you bring in scoping, it re-renders only 1 time. So 1/12 of the performance with a very, very simple setup. And believe me, real world applications are way bigger and way more, let's say, complex, problematic. Yeah. I migrated a lot of companies to a fully zoneless application in the last 1.5 years, and it's a mess, and you really have to do these optimizations. Otherwise, you will have no performance gain, but a performance drain. And yeah, we don't want this. And
yeah,
this was.
You keep saying you're doing this, and so where are you doing this interesting stuff?
So basically, it's not me that I just started it and I just work on it most of the time, but so far. Also, other people started to join the party, I would say. It's an open source repository that is called RxAngular. And I already released RxAngular/state, which is a component level state management thing. And the second package that I will release pretty soon is the template package. And this is the stuff that we discuss now. And maybe one really, really amazing fact, I had a phone call with Minko and Mishko from the Angular team 2 days ago, and I was explaining them and asking some questions about my work that I do. And Miško showed me a design document of the mark30 function that will ship in 1.5 years, maybe in Angular or whatever. It's just a paper. And I was reading the paper and I could not go to bed at this evening because it was identical to the implementation that I have running in code. So we most probably will have a lot of sessions in the future where we discuss, and I can already experiment with the community on those performance optimizations and hopefully can do a good contributions or good research for the team.
Yeah, let's get back to that design document in the end, why they might be doing that redesigns of change detection, because we still need to cover scheduling.
Yeah, you want to cover scheduling now?
Yes.
So scheduling is the most nerdy part of the whole thing. If you understood that you can collect multiple synchronous emissions within a microtask, and this is still sync code, you realize that you scheduled a piece of your logic after other code executed. So you scheduled the emission or the end of the collection in a microtask, and the other code was living in the synchronous task stack. So the browser obviously has task stacks, whatever task stacks are. I mean, really imagine them as stacks where you can put on books. You can stack books, and every book is a line that will execute or something like this. And there is a synchronous code, there is a micro task, which is a promise. Then maybe we all know the set timeout or set interval things. Those are macro tasks. They happen after all the micro tasks happening. And then you have a variety of other things. For example, before the set timeout, you have the opportunity or the chance to use animation frame schedulers, and they help you to prioritize this scheduled task for rendering. So they have higher priority. Then you have the request idle callback, which is very, very low priority, and you can prioritize the execution of some of your code all with those schedulers or scheduling opportunities. And for example, fetching data from an HTTP backend has definitely low priority when it comes to rendering, right? You don't need to render anything, so why should you use some high priority scheduling for this? HTTP request you can schedule over the request idle callback. Rendering you should always schedule over the animation frame, and everything that you should do when you try to coalesce something should in best case run over a promise. This is what I believe is a very, very good and rough overview of what is possible and where you should use what on a very low level.
Matt, do you understand all of this stuff? Some of it must be new to you.
The different stacks and such, or the prioritization. So I in the last year or so, I just learned about this event loop within the browsers and how they prioritize, and there's different stacks that need to complete before the other ones are processed and such. So my question to Michael is, how do we prioritize our code? You mentioned scheduling and such. Is there something that we can do the way we organize our code or execute it or even write it, I guess, at a component level to make it more efficient in that regard?
So my best outcome so far is that we should not push this cognitive load to the end user. So I guess it takes a lot of thinking and reading to understand the differences in scheduling. But what I believe we should provide to the end user is a very easy to understand API or naming of something where he can prioritize stuff. For example, I have rendering strategies that not only schedule, but also coalesce or don't coalesce, and call different rendering methods like detect changes, mark30, markForCheck. And every strategy has a name, and I have a global strategy, a local strategy, a detach. And I believe we should try to stick with something very simple, and we should move those scheduling things to the places where they really need to be. If you try to improve the rendering of your application, you should move all the scheduling logic into your pipes and into your directives, because this is where the rendering will get triggered and nowhere else. Just imagine some code in your class triggers re-rendering, but the part is not visible in the component tree at the moment because you have an ngIf. You would really need to sit in the template to get the best out of it. And there you can place the animation frame. The best output of all the number of renderings in the experiments that I did were with the animation frame, because this is really making sure that only when the browser has time it renders. It doesn't force the browser to stop, render stuff and then go on. It waits until the browser has time for it, but it has a high priority compared to other stuff than the idle callback. And if you fire HTTP requests, this is for example, a good thing that you can do to improve your performance outside of the template is you have your global state management and all the HTTP magic that is happening there. Maybe you use NgRx and actions and effects, and you could use a scheduler in your effects. And all the HTTP work that is done in your effects could get scheduled over the idle request, the request idle callback, because this has definitely low priority compared to a few updates. And you do it by use an RxJS operator that is called observeOn. And this observeOn operator accepts a scheduler. And then you just need a scheduler that is scheduling the stuff for you on the request idle callback. And then, the application with a one-liner is 10 times faster.
Great. So it's not only the prioritization, but it's when you make those calls. So if you can schedule and do it like you say there and in the effects, then you get that performance boost because you have that idle time and you can take advantage of that.
Exactly. You can do other stuff, and HTTP fetching has lower priority than the rest.
Okay. So those are things that we can do today then, it sounds like.
Exactly.
Right.
These strategies, Michael, they will be in the RxAngular template package?
Yes. So those strategies are basically a set of snippets of logic that I need to do the rendering. And I use different strategies for different things. Sometimes you really need to go bottom up and top down. And I want to provide those options for the user. And I have 3 different strategies. The global strategy, which is doing the same thing that markForCheck is doing, with the difference that it is working without zone. So you can use it in a zoneless application. Then I have the local strategy, which is doing the focusing only on the component itself locally. It will coalesce your changes, it will schedule your changes, and then render it. And the last thing, which is a very, very experimental, is the detached strategy, which is basically using everything what the local strategy is doing. But in addition, because zone will mess up your application a lot of times, whenever I render the stuff, I attach the view to the component, then I render it, and then I detach the view again. And then no matter who will try to re-render my component, it's not possible. And then a new state change arrives, and I attach the component view again, render it with the new value, and detach it again.
So this is using this thing that we can do ourselves, but it's really like tedious and error-prone work, where we do change detector ref, detach, and what's it called, the other one, attach or reattach?
Yeah, detach and reattach. But if you do it manually, you still run into the problem of coalescing and scoping and scheduling, and you will barely get 100% of the stuff out. If you scale, it will get slower with this approach if you don't take everything in consideration.
Very good to know. As a final thing here regarding the main content, let's get back to that Angular redesign doc for change detection. Yeah. Why would they be doing that?
So Angular is getting rid of zone. And if they want to get rid of Angular they plan it.
You heard it here first.
It's not an easy job, but it will happen at some point in the future. And to do this, we need 2 different things. And this is sketched in the design document. There is only sketched the rendering part, which we discussed already. And when I was talking to Mishko about all my findings, and he was like, yeah, this is exactly what the design document is doing, I was super happy. And I'm like, yeah. And then he was like, but you are missing one piece. And I'm like, oh my, I was shocked. I miss one piece. Oh my goodness, right? So he said, you need component level state management. And I was like, I already solved it a couple of, I solved it last year. And he was like, yeah, but you all only implemented it based on RxJS, right? So declaratively. And I was like, yes, but maybe you will laugh now. I also implemented an imperative API. So you can use set and get on this low-level component state management service. It is a service, and work completely imperatively as you would not know what RxJS is. And this is, I guess, the big benefit to provide a very slim and intuitive API and don't introduce a lot of architecture or overhead, because people need to experiment very quickly. They need to try it out. And a lot of people have their own ideas on state management, and I don't want to take their ideas away by providing some architectural directions in the implementation.
You're talking about the RxAngular state package again, right?
RxAngular state, exactly. Yes. Yeah. So both things, the template package and the state package, are part of this design document. So the design document is talking about something, and those things are implementations of the design document.
So why would they be doing this? You say they will get rid of Zone, but why would they do this and break all of our applications?
Well, maybe
there's kind of a doomsday clock, right? The Zone.js doomsday clock.
There is a doomsday clock.
5 minutes to midnight.
And you can postpone the doomsday clock, of course, whenever you want. But imagine if you patch the global browser API, you have to keep up with the global browser API's patching. So you are always one step behind. And it is a lot of work, and you have to take care about a lot of different things. And the maintenance, believe me, it's really, really awful. And they want to get rid of this concept. One of the main pain points is async await, which is, if you ask me, something that should be forbidden in the front end because you cannot cancel it. And if you use async await in a component and navigate away, it will fire. Even if a component is destroyed, whatever, it will fire. It will throw an error. It will mess up. You have no control to cancel it. But still, they care that much about async await that they get rid of Zone. I don't care about async await, but I love that they want to get rid of Zone.
Yeah, and because we got differential loading in version 7 or 8.
Yeah.
Now everyone or most application has the ES5 bundle for the really old browsers and a modern bundle as well. And as soon as you output ES 2018 bundles, which has native async await statements, now you're in trouble. Now Zone.js will not patch your async await code. And as it gets more and more normal and there's full support between all the browsers, that's the doomsday clock right there. And it's 5 minutes to midnight.
Exactly.
And sorry, GLE, you're doing awesome work, but this one, I still believe you haven't found like the cure for this. So maybe now in a not too distant future, GLE can do other awesome stuff and not have to maintain all of this testing in different browsers, and it has to work in all browsers, right? That's also what you were talking about maintenance and pain points. So
Gia helped me a lot to understand all the stuff, and he's really interested in getting rid of it too, right? So it's always a pleasure to have those discussions. And recently we created a directive because every button click will trigger a re-rendering no matter what you do. We created a directive that does pretty crazy stuff. You apply it on a button and then it will walk through all the possible events you could listen on. Look if you do it, and if you do it, it removes the event listener and adds the event listener with an API that is not zone patched. And then you can click the button without re-rendering all your application.
Yeah, I've seen this in production being a problem, a huge performance hit, because we were using click listeners to kind of do route navigator or whatever, or some other stuff, open a dialog or something. So there was really not a lot of state changing, but we had a huge tree of active components. Every time you hit a button, every component was dirty check because we didn't use OnPush. So like just one click of a button and performance drops for no apparent reason. That's a huge problem if you're not able to wrap your head around all of this optimization and rendering and change detection.
That's an interesting situation there. I wonder if we could create a list of kind of some best practices. For example, if you're clicking a button and causing change detection, and depending on when you're doing it, what kind of changes it affects, it could have a big impact. So I'm sure there's other things that could be on the list that are very similar to that.
Set interval, as Michael mentioned.
Yeah.
Like set interval 500 milliseconds, you'll re-render the whole component tree every 500 milliseconds if you're using default change detection and all of that.
I have a tricky one. So I also work on this NgRx component package, and there is an NgRx Component Store package, which is also a component level state management, pretty good one. And they also implemented coalescing of emissions, multiple emissions. Basically, it is done. You can think of a debounce operator and then putting in a promise to coalesce it. And if you use either a promise or the ASAP scheduler of RxJS, which is relying on the promise, you will coalesce everything in a single tick, and then you have the promise that will trigger zone and re-renders everything. So even on this low level, if you do low level performance optimizations and you don't have in mind that zone patches all the stuff that you use, it is useless, because no matter how many emissions you coalesce together into one, you still forget that the app still will re-render, and this is so much more expensive. And this was like stuff I ran into constantly. It is really a pain. And whenever I create a new function, I'm pretty sure when I'm done, I find one or two things that I forgot, because zone will again have a way to interfere. Just that you have a good example of how tricky it is to realize the impact of Zone.js.
Definitely. Thank you for sharing all of this with us, Michael. I mean, I have kind of teased you saying you're the only person in the world solving this problem. And other people have said, like, I use OnPush and my app is fine. So why would I need to optimize further? Well, in many scenarios, you can run into these problems.
Yeah, and I guess, I mean, the design document itself tells us that there is not only a little bit of interest, but there is like a huge interest in getting scheduling out into Angular and getting those localized rendering out, because this is one of the important design documents. And yeah, what should we do? Then just trying to implement it now. It's a good motivation, I would say.
Great. Well, before we wrap up, Matt, maybe you can go first if you have a shout out about some person that you want to point people towards. And then you can do a shameless plug or two.
Shameless plug or both? Both maybe?
Both, yeah, definitely.
Yeah, well, I was kind of thinking, I'm at two guys, right, recently. Michael, I'm going to shout you out first, because about a month or so ago, I had a pretty complex problem at work, and I was doing these subject observable kind of patterns and such. And the amount of subject observables I would need to implement this solution, that the code would just be kind of verbose. And I stumbled upon, I think it was you, Lars, that tweeted about the RxAngular state. So I implemented Rx state, and really 4 lines of code. And he had this immutable data stream. And I solved this problem very elegantly. And I was really happy, not only with the performance, but the simplicity of it and such. So for me, I think, there's a lot of ways to manage state in the component level and such. And a lot of it, could be very verbose. It could be, you could do NgRx, you could do, there's different solutions out there. But when you have a simple, elegant solution and just a few lines of code, for me, that was a big sell for me. The documentation was great, easy to understand. I looked at the different scenarios outlined there, and I said, okay, this one here kind of fits what I want to do. So I pulled that in and played around with it for about an hour, and then just came up with the solution, and worked great. So thanks, Michael. It's a great tool. The next shout out is to a friend of mine. His name is David Fotherby, and he's a UI UX guy, and he's done amazing work for these really big name companies. And if you've seen brands on TV, radio, whatever, he's done work for them. But just recently, just kind of readjusted my tracking towards Angular material, and also Angular flex layout. So those aren't things that, we think about all the time. We're like kind of knee deep in code and doing all these really cool things with managing state. But, sometimes it's really important to kind of simplify things on just layouts in general. And then using very conventional UI, UX type patterns and such. And he was just kind of going through the things he liked about material and such, and how it solves a lot of the problems that he doesn't need to think through. So anyway, I started going back to that this week a little bit in a new app that I'm working on. So Flex Layout, Angular Flex Layout is a pretty cool thing. So, and then the shameless plug, you mentioned earlier, Lars, I have the Angular Architecture Patterns book. Currently, it's free, so please go to my website, angulararchitecture.com, and get your free copy of the book. If not, catch me on Twitter, and I'll send you a link, and you can get the book that way as well.
And your Twitter handle?
Oh, at AngularLicious. That's a hard one to spell.
Do we need to spell it out? This is audio.
AngularLicious. Come on, guys. Not too hard.
Okay, Michael, who do you want to shout out?
I guess Tim Drescher from the NgRx team, because I was trying to solve a problem in another repository with collecting deprecations, and I talked to him and showed him what I did, and he was like, wow, pretty cool. And I was like, yeah, pretty cool, but I do all the work of collecting those deprecations manually. And it was painful. I guess 2 or 3 days later, he came up with the first version of a crawler that enables us to like point to a repository, point to a version, and it will crawl every single deprecation with the introduction date, the version of introduction, the link, a unique hash to this deprecation, and can also update your source code with those hashes so that you can identify the hashes, group them, and so on. And believe me, I was like, it looks pretty cool what I did and this and that, but without Tim, the amount of work that you need to collect all this stuff is like tremendous. And I guess the real benefit is his tool, because it will enable everybody to collect deprecation messages and write nicer like migration guides. This and that deprecated in that version, code example, you have to do it in the new version like this code example. And for those nice and structured guides, Tim's tool is like the best tool out there, believe me. I guess it is called Deprecation Crawler on GitHub. And it is released on NPM Deprecation Crawler.
Yeah, that's a very impressive tool. Very good job, Tim.
So good, his work. He's in general very, very helpful. The second shout out is to all the helpful people out there, because I believe you can be as smart as you want. 2 or more people will always be smarter, and to point it out very specifically, I guess you are not twice as smart with 2 people, but 4 times as smart with 2 people. So you don't double yourself, but you really, really influence yourself in a very positive way. And I cannot tell how I enjoy to work together with other people on the problem and do pair programming or such stuff. It is always very, very good.
Okay. Do you have a shameless plug?
What is a shameless plug?
Something to promote your own business or whatever thing you're doing yourself?
Of course, shameless. Yeah, I'm
we're not
shameless,
judging.
as you know.
We're not judging.
Yeah, not judging. Just be shameless. So I earn my work not by sitting in this call here and doing all my conference talks and open source libraries. I do it by help people and companies to get better Angular applications. I'm a consultant and trainer in the field of Angular, TypeScript, Ionic, and my biggest hobby is RxJS. So I guess there is a lot of stuff you can learn. And here I am. The second shameless plug is I run a workshop on the 18th and 19th of June at NG Poland. It's an online remote workshop, so everybody can join, and I will teach advanced knowledge about flattening strategies, combining streams, error handling, state management, some pretty cool UX patterns, and template rendering improvements with scheduling.
What's your Twitter handle, Michael?
My Twitter handle is Michael_Hladky.
And your Twitter name is?
And my Twitter name is Michael RX Hladky.
Of course, of course.
Of course.
The RX wizard.
Yeah. It was such an honor for me that
Matt
Matt
Podwysocki.
Podwysocki gave his head. Yeah, it was really good.
That was at NG Vikings 2019.
Yes.
And it was awesome meeting Matt. He's a really clever and likable guy. And he's put so much work into all the RX languages in the past.
Yeah.
So it was very
RX
interesting.
and IX. He's also one of the few people active on IX, which is a really cool pendant to RX.
Yeah, but for async iterables.
Yeah, so you have it pull-based instead of push-based.
Yeah, I believe that RxJS itself is kind of adding support for async iterables very soon.
Yes.
Or soonish. Yes. Sometime.
Ben has the sketch out. It looks pretty good. So I'm very happy that they will ship it hopefully soon.
Great. So I will end it by first of all saying the AsyncPipe is boring. Now we can all agree. But what's the alternative? We discussed a few here. Like the Angular team is obviously working on some way of solving this Zone.js doomsday clock. Mm-hmm. And then we have RxAngular state and RxAngular template that you've been working on with some
RxAngular template is the one that is focusing on rendering performance.
Yes. So, and just to shout out a couple of other options, there's the NgRx Component Store that Alex Okrushko is working on. That will be, I think they're planning to release a stable version soonish as part of NgRx.
State management part, so you need two parts, state management and rendering stuff.
The other part is NgRx Component, and you did the majority of that work, actually, Michael. So it contains the let directive and a push pipe, but a very naive implementation compared to all the stuff we discussed today. But it's a drop-in replacement for AsyncPipe that can support zoneless.
That's true. It is working zoneless. I basically created design documents for all the stuff I do, tests, implementations, and everything, and I had constant feedback. But for some reason that I don't know, the code didn't make it, and I just took everything that I had and published it and polished it even more under the template package. But I still, of course, will maintain and test the component package in NgRx. I will hopefully have the chance to add a little bit more features like template references to really provide a template that is visible on completion, a template that is visible on error of an observable. So some nice and handy stuff that is maybe not that technical, but still for a use for the end user.
Okay, so as the final thing here, I'd like to thank Max Koretsky and indep.dev that sponsors this podcast. And actually, in the next episode, Max is going to be a guest in this show. And the topic will be kind of going from Angular to React development and the other way as well, from React to Angular. And what's that experience like? And Max has gone from Angular to React, so he has a point of view on that. And we'll have another person representing going from React to Angular. So that will be interesting for sure. Thank you for coming, Michael and Matt. It's been a pleasure.
Welcome.
Thank you, Lars. My pleasure.
The deep dive was brought to you by indep.dev.